it.
Okay, recording. Do you guys like my intro?
The video should say.
Yes, well hopefully there should be an intro right before this video today. My son made it. Okay, so we're in the last section of this chapter and then we're moving on. You guys have a take home tonight that you should be able to do everything after you learn about similar solids, okay? So before we can learn about similar solids, we're going to review similar polygons, okay? So similar polygons are two polygons where the corresponding angles are congruent and the corresponding side lengths are proportional, okay? So we're told that triangle ABC is similar to triangle DEF, and I drew two triangles here and made them similar, okay? So that means that this angle that corresponds to this angle, those should be congruent, right? It means that this angle, which corresponds to this angle, should be congruent, and the same for the third pair, okay? It also means all their corresponding side lengths should be proportional, right? This is review. So 3:6 should be the same ratio as 4:8. Should be the same ratio as 5:10. Let's check it. So you simplify each of these. Hey! Yep, actually, the sides are proportional. So these two triangles are similar, okay? Which they did tell us. Okay, so it's asking to find the scale factor. The scale factor is just one of these ratios simplified. For every one here, there's two here. That's it, okay? The scale factor is 1/2, or you could write 1 to 2. The scale factor, as we have learned a long time ago, is a ratio, okay? If the scale factor was 2 to 1, you wouldn't just write it's 2. It's 2 to 1, okay? Any questions on that? Okay, so let's look at the same two triangles and find the perimeter of each of the two triangles and calculate the ratio of the perimeters. So what's the perimeter of this triangle? 3 plus 4 plus 5,
12.
right? And then what's the ratio, or the,
24.
sorry. Yes, and I like how you're saying it loud so the viewers can hear. Simplified? Scale factor and the ratio of the perimeters is the same.
Wow.
Thank you for the wow. Thank you. All right, now let's try the areas. Find the two areas of the two triangles. So how do you find area of a triangle? You could always look it up if you'd like, but what's the formula?
It is 1/2 base height.
Base times height is for a rectangle.
Okay, so we're at 1/2. And then 1/2.
Half of it, perfect. Okay, so what's half of 3 times 4?
3
Because
12.
if the area equals 1/2 of the base times the height, and the base times the height, base and the height are always perpendicular, right? The base and the height are 3 and 4, that's 12, half of that is, okay, so this is 6 units squared. What's the area of this one?
24.
Oh my gosh. That's not 1 to 2, is it?
1 and 4.
It is 1 to 4.
Oh, wow.
And so therefore, the area ratio is the perimeter ratio squared, or the scale factor squared. That's it, okay? The volume ratio is just cubed. So what we just learned here, this is how it's written in the book. This is just summing up what we just did. If the side length, okay, if A to B, then the area ratio is A squared to B squared. And we just saw that. Okay. So this is, and as I was saying, moving forward along with volume, the ratio for the volumes is a to b cubed. Okay, a cubed to b cubed. So let's first take a look and see whether this pair of solids is similar or not. Okay, so we have to look and see if these ratios simplify to the same ratio. Okay, so is 3 to 5. Does that simplify to the same ratio as 4 to 10 simplifies to? 3 to 5 doesn't, I mean, that's already simplified, right? This is 2 to 5. That's different. These are not similar. Okay, so what about this one? C, 7, whoops, 7.5 to 15. That's clearly 1 to 2. If you get confused, you can always use your calculator and do math frac. If you're writing this as a fraction, 7.5 over 15, and then do math frac, you'll get 1/2, or 1 to 2. So I see that for the heights. What about the 2 5s that we have here? Anyone want to notice anything about those, or want to say anything about those?
Oh, one of them is the diameter.
I heard you say one of them is the diameter.
Yeah.
Okay, so this 5 is the diameter and this 5 is the radius. So how do you want to?
2.5.
You want to make this 2.5, so we'll just compare the radii. Okay, so here this radius is, oh my gosh, 2.5, and this one is 5. So we simplify that. What do you get?
1.
Yes. Okay, so similar. They tried to trick you by giving you the diameter and the radius. Okay. How are we doing?
Good.
Fabulous. All right, this is what questions on your SOL look like just like this. Okay? Sometimes they don't even have these pictures. They just tell you the 2 cones are similar, and here the volume of the 2. What's the ratio? Oh, so it says find the scale factor. Okay, they might ask you to find the scale factor. They might ask you to find the ratio of the 2 surface areas. Okay, so first what we have to do is recognize this is a cubed to b cubed. Okay, because we're given the 2 volumes. So we're going to write that as a ratio and simplify it first. So here's it written as a ratio, and simplify it. Notice we've got a pi in the numerator and a pi in the denominator. Okay, those are going to cancel. So when you simplify 108 and 256, what do you get? Pi's are going to cancel. Do you guys have calculators? Can someone simplify 108 divided by 256, math frac, and tell me what you get? What'd you say? 27 over 64. Anyone else get that too? Can someone else confirm that? Okay, cool. All right, so now this is simplified, a cubed to b cubed. So if a cubed is 27, what's a? Do we know what to do?
9.
Does that mean that 9 times 9 times 9 is 27?
Yes, 3. It's 3.
It is 3.
I got it.
Yes, because the cube root, do you guys know how to find the cube root?
Yes.
Okay, so go to your calculator, push the math button on the left, it's like 3rd down. The 4th option is cube root, push that, type in 27, press enter. That means one number times itself 3 times gives me 27, and it's 3. So what's the cube root of 64?
4.
Done. That's it. That's all you need to know. That's all you need to know now to do your number 7 on the graded assignment as well. Okay? this is this is a more easy type of question that they would give you on the SOL, okay? The trickier ones is when they give you the volume and ask you for the ratio. How would you find the ratio of the surface areas? If you found the scale factor is 3 to 4, what's the ratio of the surface areas? This is A to B. What's the ratio of the surface areas? Yeah, so then you'd have to basically take the cube root first and then square it. So the ratio of the surface areas of these two cones would be, yeah, that's correct, 9/16. Okay? So that's really it. Let's do some more practice. Ah. Ah,
Is now a good time for me to bomb the video?
I'm recording. Come on in.
So
I'll cut you out later.
I should run through the room like this and run back like this, right? Okay, that was good. See you later.
Okay, so I don't even know. I'm in like no control of this video. All right, so ready? Okay, this problem does have a lot of, it's very wordy and it's got multiple problems in one, but let's see if we can do them separately,
Wait, what
okay?
about the secret phrase?
First secret phrase. First secret phrase is, first secret phrase is, French pressed coffee. I don't know, Miss White was telling me about this and how I should be drinking it, and she brought me some. And I haven't tried it yet. Okay. All right. All right. So cones A and B are similar with the scale factor of 5 to 2. Okay, so that is A. That's right there. That's A to B. Are you with me? We only read the first sentence. Okay. Find the surface area and the volume. We're going to do that separately. Okay. Of cone B, given that the surface area of cone A is this, and the volume is 7,450.9 cubic centimeters. All right, so if A to B is 5 to 2, the ratio of the volumes is 5 cubed to 2 cubed. So that's the ratio of the two volumes. We know one of the volumes, and we're finding the other one. So we're just going to set up a proportion, cross multiply and divide and solve for our unknown volume. Try it. I didn't have enough room. Oh, I'll put it back up when we need it.
Terrific, real.
So now we have to solve for x. Now you've got a calculator, so let your calculator do this for you. And just keep in mind, this is 125. So have you put it in the calculator? You might want to put parentheses around it. What do you get? What's your unknown volume? Now everyone has a calculator. Okay. So 7,450.9 times 2 cubed divided by 5 cubed.
59.61.
Something happened.
Wait.
My guess is, this is 2 cubed. That means 2 times 2 times 2. This means 5 times 5 times 5. So when you divide by 5 cubed, you're putting this in the calculator,
Oh, I don't put
times 2 and then caret cubed.
It's 59.
Okay?
that. All right.
You were dividing that entire thing by 5 cubed. Doesn't really matter how you put that in. But
76. Oh, wait.
what do you get?
476.
Yes, that is correct. 476 point what? 86. Now, we found a volume, so what should the units be?
Cube.
Centimeters cubed. Units cubed.
I should probably read it.
What are we dealing with here?
Centimeters cubed.
Centimeters, you said?
Yeah.
Okay.
on the problem? Oh yeah, cubic centimeters.
I just don't see it. I don't know why I don't see it. Oh, here. Square centimeters, cubic centimeters. Yeah. Okay. So that is volume. Let's do surface area. They tell us that the surface area of the cone is 2,356.2. The ratio of the surface areas is A squared to B squared. A to B, we've already identified, is 5 to 2. So the ratio of the surface areas is 5 squared to 2 squared. Is everybody with me?
Yeah.
Okay, so 5 squared is to 2 squared as this surface area is to the unknown surface area. Solve for x. Can everyone solve that?
Yeah.
Have you already done it?
No.
Okay, so do it right now. First, write this down.
Yes, possible.
2 squared. It's 9,024 feet.
You want to have this written down because when you look at this later, if you are having trouble with it, you want to be able to have something written down so you can look at it later. Okay, so what are we getting?
376.99.
And that's a surface area. So the units will be,
Units squared.
Unit squared. I'm gonna go down.
okay, excellent. And we're finished. It says round to 2 decimal places and we did that. All right, let's move on. Number 4, the 2 cylinders are similar. Find the scale factor. If we're given A squared to B squared and we need A to B, what do we do? What do we do here? What do we do here?
Simplify.
We were given A cubed to B cubed. We did simplify. And then how did we go from A cubed to B cubed to A to B?
You cubed it. Or you found
We took the cube root, right? In this problem, we're not dealing with volume.
So you take the square.
So, these problems are typically not easy. They're not easy. I get that.
Kind of like square root.
So we're given A squared to B squared and we need A to B.
Take the square root.
Take the square root.
of 288.
Exactly.
Nothing's in place.
Oh my gosh. Okay, so if A squared to B squared is this ratio. Simplify it. When you simplify this, and you could use your calculator, what do you get? You could just use math frac.
9/4.
Okay, if A squared is 9, what's A going to be?
9.
A squared is 9, so that means A is
81.
3.
because 3 times 3 is 9, or the square root
Okay,
of
3
9
over
is
2.
3,
3/2.
and this is 2. There, that's it. That's the scale factor.
That's it?
That's it.
Nice. That was easy.
Done. All right, we have 2 more practice problems. Now these 2 practice problems, ladies, I'm recording and I really appreciate your
You need to chill out.
thanks.
You
Okay.
need to chill out.
All right, I added these 2 problems because they are, sometimes the questions on the SOL are worded kind of more like this. And I want you to see that they're very similar to what we just learned. Okay, these 2 problems are virtually identical. All right, so if the side lengths of a cube are doubled, okay, how does this change the surface area or the volume? Okay, so they don't give you a diagram. It's usually like the problem looks like that. That's it. Okay, most of the time I ask students to draw 2 pictures. Okay, so we've got ourselves, all right, so if it's doubled for every side length here, that was 1 inch or 1 centimeter, then it'd be 2 centimeters, okay? Just to give you a visual of what's happening here. So if you know the scale factor is 1 to 2, that's your A to B.
It's only do 1 to 2.
The surface area ratio is A squared to B squared. So it'd still be 1 because that's 1 squared is just 1, right?
4.
That's going to be 1 to 4. And the volume ratio will be 1 cubed to 2 cubed. What's that? What's 2 cubed? 2 times 2 times 2. Okay? This is the ratio between the surface areas. So the surface area is 4 times bigger. And the volume is 8 times bigger. And the last one is really similar to this. And I'll come back to that in just a second so you can write it down. Is that not? Here we go. So here's what the question will look like. If the diameter of a cylinder is cut in half, how does it change the surface area of the volume? Okay? Well, draw yourself 2 cylinders and whatever numbers you want. I just picked 10 and 5. They were nice numbers to cut in half. Okay? When you simplify this, you get 2 to 1. Okay? So the numbers are going to be the same as the last one. So if A to B is 10 to 5, when you simplify that, 2 to 1. The ratio of A squared to B squared is just going to be, what's 2 squared?
4.
The surface area is going to be 1/4 of the original surface area, and the volume is going to be 1/8 of the original volume. Okay? And we are finished.
Hey.
Oh, what's the second secret phrase? Second secret phrase is
Chicken fried rice.
chicken fried rice. Thanks for coming out. That was a good one.
But I love it.